Bismillahirrahmanirrahim. Assalamu alaikum, dear students. The topic of discussion today is instruction pipelining. I welcome you all to the next online class of computer architecture. So, let us first introduce instruction pipelining. Instruction pipelining or simply pipelining refers to the concept of dividing an instruction into more than one stages and then executing multiple instructions at the same time but at different stages. It allows us to increase the resource utilization. Well, instruction pipelining, or to put it simply, pipelining is the concept कि जिसमें हम एक इंस्ट्रक्शन को मल्टीपल स्टेजेस में डिवाइड करते हैं. So, इससे होगा क्या कि instead of waiting for one instruction to finish entirely before starting the next, we execute multiple instructions at the same time, लेकिन हर एक instruction different stage में execute हो रही होगी. इससे क्या होगा कि this approach allows us to maximize resource utilization within the processor. Now, how it is going to happen? We have two models for it. Let us discuss the first model, two-stage model for pipelining. Now, the two-stage model is the simplest version of pipelining. Here, we divide an instruction processing into two independent stages. The first stage is the fetch state and the second one is the execute stage. Now, what happens is that fetch stage mein we get the instruction from the memory. We in fact fetch the instruction from the memory. And execute may we carry out the instruction or we carry out the operation that we have to performed in the instruction. So according to two-stage model of pipelining, an instruction is divided into two stages, fetch and execute. Now, how does this work? The first stage fetches an instruction and places it in the buffer. जो short term memory है हमारे पास. The first instruction is fetched and stored in the buffer. As soon as the second stage is free, the first stage passes that buffered instruction जो हम already fetch कर चुके हैं over to the second stage. Now, while the second stage is getting executed, it means कि वो instruction जो हमने already fetch की थी, जब वो second stage में आ गई है और वो execute हो रही है, the first stage uses those idle memory cycles to fetch the next instruction in parallel. Now, आप इस चीज को समझने की कोशिश कीजिए कि हर इंस्ट्रक्शन की एग्जीक्यूशन के दो स्टेजेस हैं. पहले स्टेज में वो इंस्ट्रक्शन फैच हो गई एंड सेकंड स्टेज में वो फैच्ड इंस्ट्रक्शन एग्जीक्यूट हो रही है. नाउ while the second stage is getting executed, the cycles may be used to pre-fetch the next instruction. तो अब आप देखें इस वक्त पाइपलाइन में दो इंस्ट्रक्शन हो गई. एक इंस्ट्रक्शन जो पहले फैच हुई थी वो एग्जीक्यूट की जा रही है और मीनवाइल जब वो पहली इंस्ट्रक्शन एग्जीक्यूट की जा रही है तो दूसरी इंस्ट्रक्शन को फैच किया जा रहा है. तो दोनों स्टेजेस जो हैं वो पैरेलल में परफॉर्म किए जा रहे हैं लेकिन विद डिफरेंट इंस्ट्रक्शन. तो ये while one is getting executed and उस दौरान क्योंकि पहला स्टेज फ्री है तो हम नेक्स्ट इंस्ट्रक्शन को पहले से ले आते हैं. दिस कॉन्सेप्ट इज कॉल्ड प्रीफेच. ठीक है, this concept is called prefetch. So as the slide says, the first stage fetches an instruction and buffers it. When the second stage is free, the first stage passes it to the buffered instruction. Now when new instruction is being executed, the first stage जो कि अब free है uses those cycles in which the memory is not referenced and fetches next instruction in parallel. Now, this process of fetching an instruction in advance before the previous instruction has finished execution is called prefetch. Prefetch पहले से हम fetch करके next instruction को ले आए हैं. एंड नॉट टू फॉरगेट अ वेरी इंपॉर्टेंट पॉइंट कि मैंने इंट्रोडक्शन में कहा था कि बोथ ऑफ दीज फेजेस आर और these stages are independent, means ये एक दूसरे पे डिपेंड नहीं करते. While one is getting executed, the other one may also get executed with a different instruction. Now let us talk about the issues with the two-stage model pipelining. Ideally, as we have talked about it in the earlier slide, कि one is getting executed and the other one is getting prefetched. I'm talking about the instruction. इसी तरह जब जो prefetch instruction है वो जब execute होगी तो we may like bring the next one in as a prefetch instruction. So ideally this should double our speed as both the stages are independent and are running in parallel, and the processor does not have to wait for the fetch of the next instruction. देखिए, जब एक इंस्ट्रक्शन एग्जीक्यूट हो रही है तो दूसरी इंस्ट्रक्शन तो उस दौरान ऑलरेडी प्री फैच कर ली जाती है, तो प्रोसेसर को पहली इंस्ट्रक्शन के एग्जीक्यूशन के बाद दूसरी इंस्ट्रक्शन को फैच करने के लिए वेट नहीं करना पड़ेगा क्योंकि वो इंस्ट्रक्शन तो पहले से फैच की जा चुकी है. सो आइडियली दिस शुड डबल आवर स्पीड as both the stages are running in parallel. तो आइडियल सिनारियो में तो हमारी जो एग्जीक्यूशन की स्पीड है वो डबल हो जानी चाहिए. however in practice however in practice like it is not like that. We encounter two main issues. ठीक है, so practically it is not possible. वो क्यों पॉसिबल नहीं है, अब हमने उसके दो रीजंस को समझना है कि थियोरेटिकली जब हमने इसके कॉन्सेप्ट को समझा तो वी बिलीव कि आपकी एग्जीक्यूशन स्पीड जो है वो डबल हो जानी चाहिए, लेकिन that does not happen. So why it does not happen, we have to understand those two reasons now. Okay, so reason number one is the execution time of an instruction is normally larger than the fetch time because it may involve multiple memory references, so fetch stage may have to wait for the execution stage to get finished. देखिए, आइडियली तो हमने ये कहा था ना कि आपकी जो एग्जीक्यूशन है, जिस दौरान एग्जीक्यूशन हो रही है उस दौरान हम दूसरी इंस्ट्रक्शन को प्री फैच कर रहे हैं और दोनों स्टेजेस जो हैं वो इंडिपेंडेंट हैं, लेकिन वहां पे हम ये एज्यूम कर रहे थे कि बोथ दी स्टेजेस टेक इक्वल टाइम. सो इन दिस वे प्रोसेसर रिसोर्सेज और प्रोसेसर टाइम वुड नॉट बी वेस्टेड एट ऑल. लेकिन रियलिटी इज द प्रैक्टिकल थिंग इज कि जो इंस्ट्रक्शन की एग्जीक्यूशन का टाइम होता है ना वो फेच टाइम से ज्यादा होता है. तो फॉर एग्जाम्पल अगर एक इंस्ट्रक्शन जो है वो 3 सेकंड में फेच हो रही है तो एग्जीक्यूट वो 6 सेकंड्स में होगी. तो अब जब वो एग्जीक्यूट हो रही है और दूसरी इंस्ट्रक्शन हम प्री फैच कर रहे हैं तो जो प्री फैच का टाइम है वो कम है, एग्जीक्यूशन का टाइम ज्यादा है, तो प्री फैच होने के बावजूद भी इंस्ट्रक्शन को वेट करना पड़ेगा ताकि एग्जीक्यूशन स्टेज कंप्लीट हो जाए तो फिर नेक्स्ट इंस्ट्रक्शन जो कि प्री फैच कर ली गई है उसको हम एग्जीक्यूट कराएं. तो आइडियली अगर इन दोनों का टाइम बिल्कुल सेम होता, फेच का टाइम भी 3 सेकंड होता और एग्जीक्यूट का टाइम भी 3 सेकंड होता, तो फिर तो आइडियल सिनारियो था हमारी ओवरऑल जो एग्जीक्यूशन है वो डबल अप हो जाती, स्पीड अप उसकी स्पीड डबल हो जाती. लेकिन क्योंकि दिस इज अ वेरी इंपॉर्टेंट पॉइंट, द एग्जीक्यूशन टाइम ऑफ एन इंस्ट्रक्शन इज नॉर्मली मोर देन द fetch time, so it's still the fetch stage has to wait for the execution stage. तो इससे हमारा वो जो आइडियल सिनारियो है ना वो थोड़ा सा डिस्टर्ब हो जाता है. हम रिसोर्स की यूटिलाइजेशन तो कर रहे हैं, टाइम बचा रहे हैं, लेकिन वो आइडियल सिनारियो नहीं है, हम डबल अप नहीं कर सकते. एंड वन मोर थिंग के व्हाई, अगर किसी स्टूडेंट के माइंड में आए कि व्हाई इट इज के एग्जीक्यूशन टाइम इज मोर देन द फेच टाइम, क्योंकि एग्जीक्यूशन जो है एक तो वो डिपेंड करता है कि आपका कौन सा आर्किटेक्चर फॉलो किया जा रहा है, रिस्क है या सिस्क है, और सेकेंडली नॉर्मली एग्जीक्यूशन के अंदर मल्टीपल मेमोरी रेफरेंसेस इन्वॉल्व होते हैं क्योंकि there can be multiple operands involved in the execution of an instruction, so we have to visit the memory multiple times, so that is why जो आपकी एग्जीक्यूशन टाइम है वो ज्यादा होता है. और सेकंड जो रीजन है दैट इज द ब्रांच्ड इंस्ट्रक्शन. ब्रांच इंस्ट्रक्शन उस इंस्ट्रक्शन को कहते हैं विच इन्वॉल्व्स अ जंप. which involves a break of sequence. For example, if we are executing the fourth instruction, we are expected to execute the fifth instruction. So PC would contain the address of the fifth instruction, but then suddenly we realize that fourth instruction is a branched instruction. It asks you to jump to skip 5 and to jump to like 6 or 8 or 10. So this type of instructions are called branched instruction, right? So if the current instruction is a branch instruction, which requires a jump in the sequence, the instruction we prefetched become useless. So आप फॉर एग्जाम्पल करंटली 4 को आप एग्जीक्यूट कर रहे थे, तो जो आपने फिफ्थ इंस्ट्रक्शन को प्री फैच किया हुआ था, ड्यूरिंग एग्जीक्यूशन आपको पता चला कि द करंट इंस्ट्रक्शन इज अ ब्रांच इंस्ट्रक्शन, तो जिस इंस्ट्रक्शन को आप प्री फैच करके लेके आए थे वो यहाँ पे यूजलेस हो जाएगी. So it must be discarded and we have to fetch the correct instruction from the new memory address, right? तो जो आपने working की है, so in this case the parallel prefetch instruction will be discarded and new instruction will have to be fetched from the very start. So ये वो दो reasons हैं जिसकी वजह से हम ideal scenario नहीं achieve कर सकते, but still two-stage model for pipelining is much better than simple and sequential execution of the instruction, and it results in better optimization and better use of the processor resources, right? Now, multiple stage instruction pipelining. Now, moving to multiple stage pipelining, and remember that we have to address the limitations of the two-stage models, okay, जो हमने पीछे discuss की. Now, in order to cover up the issues of two-stage model for pipelining, the instruction processing must be divided into multiple stages for being pipelined. Now, a better model decomposes it into 6 stages. एंड हमने दो स्टेज से आगे बढ़कर अब इंस्ट्रक्शन की एग्जीक्यूशन को 6 स्टेजेस में डिवाइड कर दिया है, और हम ये एज्यूम कर रहे हैं कि ऑल द स्टेजेस टेक राउंड अबाउट इक्वल टाइम. सो the problem of two stage model for pipelining will be solved to large extent. Let's see how. सबसे पहले तो वो 6 स्टेजेस हैं क्या, ठीक है. Those 6 stages are fetching, which means reading the instruction and storing it in the buffer. Then we have to decode the instruction in the next stage. And by decoding, we will identify the opcode and the operand. Then we have to calculate the operand address. Then in the next stage, we have to fetch the operand. Then in the next stage, we have to perform the execution. So EI is execution of instruction. And then in the last stage, we are going to store the result in the memory. So those 6 stages are fetch, decode, calculate operand address, fetch operand, execute instruction, and write the result back in the memory. Now, so now this is like very nice and beautifully designed diagrammatic presentation of the multiple stage pipelining. You can see, okay, we have 3 instructions in the pipeline right now, and assume that 1, 2, 3 are like time periods. You can consider it as a second or as a unit of time. So आप देख रहे हैं कि इस वक्त पाइपलाइन में we have 3 instructions. The first instruction is basically has been fetched, it has been decoded, the calculation of the operand address was done, then the operand was fetched, then the instruction execution happened, and then the result was written back. अब फर्स्ट इंस्ट्रक्शन जब डीकोड हो रही थी तो उस दौरान हमने नेक्स्ट इंस्ट्रक्शन को फैच कर लिया, तो अब हमारे पास पाइपलाइन में 2 इंस्ट्रक्शंस हो गई. और फिर सेकंड वाली इंस्ट्रक्शन जब डीकोड हो रही थी, द फर्स्ट वाज कैलकुलेटिंग द ऑपरेंड एड्रेस, द सेकंड वन वाज गेटिंग डीकोडेड, तो उस दौरान हमने थर्ड इंस्ट्रक्शन को जो है वो प्री फैच कर लिया, ठीक है. सो अब आप देखें कि 3 इंस्ट्रक्शन एग्जीक्यूट हो रही हैं लेकिन डिफरेंट स्टेजेस पे. फॉर एग्जांपल कंसीडर द फिफ्थ स्टेज. तो फिफ्थ स्टेज पे इंस्ट्रक्शन नंबर 1 क्या कर रही थी कि इट वाज गेटिंग एग्जीक्यूटेड, एग्जीक्यूट इंस्ट्रक्शन का स्टेज चल रहा था. सेम स्टेज पे इंस्ट्रक्शन नंबर 2 क्या कर रही थी, इट वाज फेचिंग ऑपरेंड. एंड सेम स्टेज पे इंस्ट्रक्शन नंबर 3 क्या कर रही थी, इट वाज कैलकुलेटिंग द ऑपरेंड एड्रेस. So 3 different instructions were getting executed at 3 different stages, right? So एक ही वक्त में we are executing three different instructions, and all of them are getting executed in different stages. Now, up, let's suppose we assume that, as I told you, consider this time period as cycles. So if we are doing sequential execution of these instructions, so it will take 3 into 6, 18 cycles in total, right? Lekin if we are doing the pipelining execution, then we have the formula. Class, this is very important for you, for your exam as well. We have the formula: total number of cycles is equal to k plus n minus 1, where k is the number of stages, and not to forget we have 6 stages in that example, so k becomes 6, and n is the number of instructions, so n becomes 3, as we had 3 instructions. So now put it in the formula, substitute the values k plus n minus 1, we get the 8 cycles. So what this slide is saying, if there are 3 instructions and there are 6 stages for each instruction, so if you are doing sequential execution, it will take 18 cycles in total. But if you are doing pipelining execution, it will take only 8 cycles according to this formula. Now again, we have like issues with the multiple stage pipelining as well. So issue number one, we assume that all the stages are executed in parallel, जैसे हमने start में कहा था कि they roundabout take the same time and independent. However, three stages, जो तीन different stage हैं, जिसमें एक है fetch instruction, एक है fetch operand, एक है write result. All of them involve memory references, so it may not be practically possible. So हमने ये एज्यूम किया मल्टीपल स्टेज पाइपलाइनिंग में कि ये स्टेजेस जो हैं वो सब इंडिपेंडेंट हैं और सब जो है वो पैरेलल में एग्जीक्यूट हो सकते हैं, बट अगर आप गौर कर लें, सो देयर आर थ्री स्टेजेस जिसमें फेच इंस्ट्रक्शन, फेच ऑपरेंड एंड राइट रिजल्ट है। ये तीनों जो हैं वो मेमोरी रेफरेंसेस से रिलेटेड हैं। सो इट मे नॉट बी प्रैक्टिकली पॉसिबल कि तीन डिफरेंट इंस्ट्रक्शन तीन डिफरेंट स्टेजेस में मेमोरी रेफरेंसिंग कर रही हैं, सो दे मे स्टिल बी वेटिंग फॉर द अदर वन के उसका मेमोरी रेफरेंस कंप्लीट हो तो मैं करूं, बिकॉज ऑफ द लिमिटेशंस ऑफ द रिसोर्सेज। However, ये हो सकता है कि there is a possibility that the data may be present in cache or register. So in that case, maybe के fetch operand or write back the result may not occur at all. But if they are referring to the memory at the same time, so it may like create a problem. Second issue, again, a branch instruction may invalidate several pre-fetched instructions. So occurrence of an interrupt will also do the same. Now branch instruction again, जैसे वो two stage pipelining में if the current instruction that is currently getting executed is a branch instruction, तो वो free pre-fetch instruction को discard करवा देती है and we lose all the benefits of the pipelining. Same occurs over here as well कि if during execution हमें पता चला कि instruction is a branch instruction which requires a jump in the sequence, so जितनी भी pre-fetched instruction है उन सबको हमें डिस्कार्ड करना पड़ेगा. So again, it is a big issue in the multiple stage pipelining. So as you can see, okay, there were like 7 different instructions in the pipeline, and during the execution of the third instruction in the 7th cycle, we realized that third instruction is a branch instruction. नाउ थर्ड इंस्ट्रक्शन की एग्जीक्यूशन तक हम इंस्ट्रक्शन नंबर 4, 5, 6 एंड 7 को प्री फैच कर चुके थे. ना सिर्फ प्री फैच कर चुके थे बल्कि 4 5 के मल्टीपल स्टेजेस को भी एग्जीक्यूट कर चुके थे. लेकिन इंस्ट्रक्शन 3 की एग्जीक्यूशन के बाद वी रियलाइज के बाकी की इंस्ट्रक्शन जो है वो हमें डिस्कार्ड करनी पड़ेंगी एंड वी जंप टू इंस्ट्रक्शन नंबर 15 और इंस्ट्रक्शन नंबर 4, 5, 6 एंड 7 की जो प्री फैचिंग हो चुकी थी हमें उसको डिस्कार्ड करना पड़ा. सो वी लूज ऑल the advantage of having pipelining. Then we have the issue number 3, and then this issue says that the CO stage, that is the calculation of operand address stage, may depend upon the contents of the register, which may be altered by an instruction also present in the memory. Now this is a very important point कि जो operand address calculation है, this stage might depend on the content of a specific register. लेकिन as you know कि register are part of process, so there is a possibility that if a previous instruction currently in the pipeline is in the middle of altering that same register, the CO stage might grab the wrong data, and इसको हम synchronization nightmare कहते हैं, that we have to manage. So अगर आपके किसी एक इंस्ट्रक्शन जिसमें आपने ऑपरेंड को फेच करना है एक ऐसे रजिस्टर से, और उस रजिस्टर को पाइपलाइन में मौजूद कोई और इंस्ट्रक्शन जो है वो यूज करके उसके कंटेंट्स को चेंज कर चुकी है या अपडेट कर चुकी है, so this may be a very big problem and you might end up getting the wrong data, right? Then we have the fourth issue. For a single instruction, there exists some overhead from transition from one stage to another, that is moving data from buffer to buffer. It can increase the overall time of execution of a single instruction. देखिए, we have increased the number of stages, but by increasing the number of stages, now we have to manage the every stage independently. और जब हम data को move कर रहे हैं ना एक stage से दूसरे stage पे, so this is also an overhead. Overhead का मतलब ये है कि it also consumes resources. It requires time. It is a burden on the processor, right? So it is expensive. So moving data from one buffer to the next as an instruction transitions between stage is not instantaneous. Like for a single instruction, this transition time can actually increase the total time it takes to execute compared to a non-pipelined system. So ये भी हो सकता है कि स्टेजेस बढ़ाने से आपकी वो कम्प्लेक्सिटी इतनी बढ़ जाए कि स्टेज टू स्टेज ट्रांजिशन की वजह से जो आपकी एक सिंगल इंस्ट्रक्शन का एग्जीक्यूशन टाइम है वो अब नॉर्मल सिंपल एग्जीक्यूशन से ज्यादा हो जाए. So this is also a possibility. Then we have the next issue. इसका मैं पीछे भी डिस्कस कर चुका हूं कि the more the number of stages, more logic will be required to handle memory and register dependencies. So the logic controlling the gating between stages can become more complex than the stages being controlled. So the more the number of stages, more logic will be required to handle memory and register dependencies. सो इवेंचुअली द गेटिंग लॉजिक, गेटिंग का मतलब है एक से दूसरे में एक स्टेज से हम आउट होके दूसरे स्टेज में जब एंटर होते हैं, सो द गेटिंग लॉजिक दैट कंट्रोल्स द फ्लो between stages becomes more complex and bulky than the actual processing stages themselves, right? So ये जो गेटिंग का लॉजिक है एक से दूसरी उसमें ट्रांसफॉर्म होने का, that becomes very complicated. Now next topic in the pipelining is pipelining hazards. What is a hazard? First of all, please note the definition. When things go wrong, let me simply explain. When things go wrong and the pipelining has to stop or slow down, we call that hazard. ठीक है? जब things don't go as per expectation and pipelining is like temporarily slows down or stops, these things are called hazards. So pipelining hazards are those situations where the normal execution of the instruction pipelining is halted. It results in some of the stages being idle. So there are three different types of pipelining hazards: resource hazards, data hazards, and control hazards. Now let us first explain the resource hazards. Resource hazards occur when two different instructions at two different stages require for the same resources. As a single resource cannot be given to both, so this will be executed sequentially and one instruction will have to wait for the other instruction. So as I explained, a resource hazard happens when two different instructions जो कि different stages में execute हो रही हैं, they require the same resource. For example, if the three instructions are the fetch, decode, and write back stages, and all three need to access memory, so this cannot be done in parallel. So one instruction has to wait, forcing them to execute sequentially. we want to like apply the pipelining, but as something cannot be done in parallel. For example, if it is not possible that all three are using or referencing the memory at the same time, so eventually what happens, we will have to like stop the or other two instruction, and they will have to wait for one of them to complete its referencing of the memory, and then the other one may get executed. The second one is the data hazard. Now, data hazards are the situation when an instruction tries to read the data which is already read and being processed by some other instruction at some other stage. This may lead to data inconsistency, for example, inefficient pipelining utilization. Data hazard occurs when an instruction tries to read the data that is currently being processed or modified by another instruction किसी और pipeline में. ठीक है, so this leads to data inconsistency क्योंकि obviously it may have read and it may have updated that data. So we have, there are three specific types of it. One of them is read after write, the other one is write after read, and the third one is write after write. So read after write में क्या होता है कि an instruction tries to read a value before a previous instruction has finished writing the update to it. Previous instruction ने अभी उस वैल्यू को अपडेट नहीं किया, और जो न्यूअर इंस्ट्रक्शन है इट इज ट्राइंग टू रीड अ वैल्यू बिफोर द प्रीवियस इंस्ट्रक्शन हैज फिनिश्ड राइटिंग द अपडेट टू इट. सो आपको जो वैल्यू मिलेगी दैट वुड नॉट बी अ करेक्ट वैल्यू. राइट आफ्टर रीड क्या है कि एन इंस्ट्रक्शन राइट्स टू अ लोकेशन बिफोर अ प्रीवियस इंस्ट्रक्शन हैज हैड अ चांस टू रीड द ओल्ड वैल्यू. नाउ जो प्रीवियस इंस्ट्रक्शन थी उसने जो एग्जिस्टिंग वैल्यू थी उसको रीड करना था, लेकिन अभी उसने उस वैल्यू को रीड नहीं किया कि न्यू इंस्ट्रक्शन ने उस वैल्यू को अपडेट कर दिया. सो अगेन जो ओल्ड इंस्ट्रक्शन को वो वैल्यू जब मिलेगी, सो दैट वुड बी एन इनकंसिस्टेंट वैल्यू और सिंपली से एन इनएक्यूरेट वैल्यू. एंड राइट आफ्टर राइट क्या है कि टू राइट ऑपरेशंस हैपेंस इन द रिवर्स ऑर्डर ऑफ व्हाट इट वाज इंटेंडेड. नाउ दिस इज लाइक, इसको इस तरह आप समझिए कि the intention was कि first value a would be written and then value 2 would be written or updated. For example, if we have a number n and first we have to subtract 3 from it and then we have to multiply it with 8. But if you do it in reverse order, if you multiply it with 8 first and then subtract 3, so you would end up getting an incorrect value. The third one is the control hazard. Again, now this is basically related with the branch instruction, and I have already explained that if a branch instruction occurs, if we realize during the execution of one instruction that this is a branch instruction, all the prefetch instructions would have to be discarded. That is what the control hazard is. This branch instruction is the biggest problem, and it proves really expensive for the pipelining to handle. Now, handling branch instruction with pipelining, as we have already realized, it is a very big issue. So we have to come up with some sort of solution to deal with the branch instructions while implementing pipelining. So there are multiple ways of handling branch instruction. I have discussed three of them here. That is the multiple stream, loop buffer, and branch prediction. Now, what happens in multiple streams? We essentially run two different pipelines for the two different possible paths that the branch might take. Like if we for just think about a possibility of having a if else statement in the program. There are two possibilities. If the condition is true, one particular statement would be executed, and if it is false, some other decision would be taken, and some other instruction out of sequence would be executed. And we do not know if the condition would be true or false. So what we do, we basically maintain two different pipelines for both the possible paths. Now, while this sounds great that in both the cases the next instruction would already be prefetched, but it leads to bus and register congestion because both streams are fighting for the same resources. Now, you will realize this in the next slide. Yes, here it is written. Okay, the problem with this approach is that although it sounds great that you are maintaining multiple pipelines for both the possibilities, but it will result in bus and register congestion. What it means that both the streams will be competing for the same resources, and pipelining multiple branch instruction may require to use multiple pipelines. So multiple pipelines require resources, require more management, require handling of more complexity. So obviously this may end up decreasing the performance. The next possibility is the loop buffer. It is another method of using or handling the branch instruction. This is a very small, very loop buffer is a very small, very fast memory that stores recently executed instructions, just like normally the cache memory contains the recently executed instructions. Now, what happens is that if a branch instruction occurs and we have to skip and certain number of instruction and we have to jump to a particular instructions. So before going all the way to the main memory for a branch, the processor checks the buffer first. So in case if it was a recently executed instruction, so it would still be present in the buffer. So this is incredibly effective for loops or branches that jump just ahead, like just a few locations ahead. So अगर आपने for example in the case of the loops, the loops में instructions are repeatedly performed. So if there are four instructions that are inside the body of the loop, the first instruction is executed and then it is stored in the loop buffer. Then the second, third, and fourth instruction are executed. Now, next fifth instruction would not be executed. The first instruction would be re-executed because these four instructions are inside the body of the loop. So जो first instruction है वो loop buffer में अगर पड़ी होगी, so it can be comparatively easily fetched as compared to going to the memory again and calculating the address of the instruction and then fetching the instruction. So let me read it out. In a loop buffer, a small buffer is maintained. Recently executed instructions are stored in it. In case of branch instruction, and I hope you remember, branch instruction is an instruction which breaks the normal execution and jumps to some other part or jump to some other instruction that is non-sequential. So in case of branch instruction, first the loop buffer is checked. If the instruction is not found in the memory is then referenced, obviously. So it is good for loop execution and good for situation when the branch instruction is a few location ahead of the current instruction. And then the next method is the branch prediction, where we guess which way the branch will go. There are three main strategies: predict never, predict always, and predict by opcode. So in predict never, we assume that the branch is never taken and just keep fetching the instruction in the same sequence. So if there is a if statement and if the condition is the condition is true, so the next instruction in the execution would be in the sequence would be executed, and if the condition is false, there is a jump. So we assume that the branch will never be taken. So we just normally prefetch the next instruction, which is according to the normal execution. The next one is the I think I missed one. Predict never, predict always. In predict always, we assume that the condition will be true, and we immediately start prefetching the branch instruction. So predict never and predict always. In predict never, we assume that the branch would never be taken, and in predict always, we assume that the branch will definitely be taken. So we fetch the instruction. And then this one, the predict by opcode. We look at the type of instruction. Okay? We look at the opcode, and certain categories of instructions are statistically more likely to branch than others, and we fetched based on those odds, right? So हमने क्या करना है, हम ऑप कोड को या इंस्ट्रक्शंस को डिवाइड कर लेते हैं, कैटेगराइज कर लेते हैं, एंड देयर आर सर्टेन कैटेगरीज in which branches are more likely to be taken. So if the opcode belongs to that category, so then we are going to prefetch the branched. And if the opcode belongs to a category where the branches are mostly not taken, as it is written in the second point, if opcode belongs to category where branch instruction is most likely to occur, then the branch instruction is prefetched. Otherwise, instructions are fetched in sequence, right? So these are different ways proposed by the different researchers in their research articles regarding handling the branches or handling the branch instructions. So this was the discussion regarding the pipelining. If you have any question, please note down and ask me. I'll definitely be answering them. Thank you very much. Stay blessed, everyone.